Hey guys, we have another project and is line boring today. So I know some of you like it, some of you will probably tell me to go back and work on a sawmill. I'll get back to that. I gotta pay for some stuff. So to buy sawmill parts and parts for everything else I do, I have to do painting work. So today we are going to be working on this right here. So you might be saying, what the heck is this? Well, the customer brought me this, which as you can see, is twisted. That will no longer work. This is a, often referred to as dog bone link off an excavator. It's up by the bucket. Little Kubota excavator. This one's twisted. He needed the part back, ordered an aftermarket one. Well, didn't come out the same. I pulled all the bushings out. As you can see, these big bosses are the same. That's good. Length is the same. That's good. The new bosses are wider, and the bushings are also larger. I think these were 65 and these are 70 millimeter. This part with all the great sourcing of stuff right now is, I think he said it was like at least 10 days out for the quickest he could possibly get one. He needs it faster. So, he brought me the old one and the new one. He actually had fresh bushings, or pretty fresh bushings in the old one before this happened. So, I pressed the bushings out of here, and they don't fit in here. Let me show you. So these are brand new bushings that came out of the new aftermarket part, and these are, you can see they're actually really good shape, still have paint on them and stuff, out of his broken one. And big size difference. So I'm going to reuse these bushings. Got new grease seals for them. This piece fits in this hole. The one I need to put in doesn't fit, way too loose. So I got it clamped at the end of the bench, and we're going to set up the line boring and bore welding setup on here. I'm going to take the bore welder, weld up these bores. I should have enough stroke because this is narrow enough, which is awesome because when I don't have enough stroke and I have to do it as 2 holes, twice the work. So I should be able to go weld both bosses, switch over to my boring setup and bore both bosses the correct dimension. I got new measuring tools, super excited about that. Will make this a lot easier to get to size. And then we'll press in bushings, get them centered up. Actually, before we press them in, we will go and take this over to the mill, and we will mill the outside off both these bosses so they'll be nice and square and the correct width. Alternatively, I might actually do a little trick with the line borer. Maybe I'll do it just to show you. You can, they make a facing tool. It's over $3,000. I don't have one. I'll get one eventually, but the numbers of times I need that isn't really all that much. But one trick I can do is I can stick the cutter out and manually feed it in until it just cuts a face, and then shut it off. Stick the cutter out some more, manually feed it in, and on something this size, probably 3, maybe 4 passes, I can shave this down to the right width. It'll take a little bit of measuring to come in and get the right width, but I can cut this down. It'll be perfectly square to the bore. I'll get to the right width. Then I can press these in, get them centered, and he's got the grease seals. He said he ordered them. I might have some if I dig in my stuff. But we'll stick the bushings in, and then we'll put the grease seals in, and then I don't know if I'll take you on the road. I got to do the end of the stick for the same machine. I just did the thumb the other day. If I had to guess, if I've done this much stuff, I bet I'll be back to do even more on it. These little old machines tend to just kind of get worn out. All it takes is one owner to not be very good at greasing, or someone to be really hard on it, and you have a mess. Even if you are good at stuff, it does wear out over time. But we're going to go and get this set up, welded, bored, faced, pressed, and like, subscribe, and comment. So to set up the line boring machine, first put the boring rod in that I'm going to use, and then I put some cones on and some lock collars, and by locking down the first collar right here, I then have one side held in, and then stick a piece of keyway through on the other side and use a pry bar like that to really tighten everything up, and then I can lock the second lock collar on there. That makes the boring bar centered on the existing hole. Now if it's egged out, sometimes you have to mess that a little bit to get just right, but that sets the center line for the ultimate finished hole. And then stick the bearings on. It's a pancake hood. They're sort of funny. Good for pipe welding. And anywhere you need to be really close to your work. I didn't really need to be close for this, but it's a really nice hood. And what I'm doing here is I've got some pieces of 1 inch by, I think it's 3/8, just regular steel bar, and I weld them onto the part on one side, and I weld the other side onto the plate that the bearings are bolted to. I put 4 on each side, and that tends to be rigid enough to give me a good setup for boring, and it holds the bearing outboard enough that I can get in behind it to set the cutter thickness. I try not to use huge welds just because too much weld makes it a pain to get off later, but too little and it might break, so I tend to weld one side really well and the other side gets a little dot, and I can come in and cut the little dots and kind of fold it out. But this is kind of the standard way to do it. It works really well. I guess if you had a part that had a good bolt flange, you could cut a plate and bolt it on instead, so you didn't have welding, but by the time you line bore it, you've already cooked the paint off it anyway, so you might as well weld onto it and have a really good setup. You can always grind it nice and smooth, and it's usually just fine. Now you can see I got 4 of them on each bearing, holding everything in place. And once the bearings are in, I'm loosening the lock collars so I can take the boring bar out, since you have to take the boring bar out to get the cones and collars out, because if you don't get those out, you can't do the job. As you can see, this locked up pretty well. You usually fix that by loosening these up. This head bearing has 2 rigid bearings in it, and as the weld shrink, you can twist it a little bit. The tailstock, that's got the bearing swivels on it. I don't think it's quite a spherical bearing, but I don't know. I'm sure it's the wrong term for it. But the tailstock bearing will pivot a little bit. The headstock bearings do not. So when this gets welded on, sometimes it will lock up, and just adjust for it. I loosen these up. Those are the mounting bolts. See, now it'll start to move again. And just gotta get these nice and loose. Come in with the Allen. And snug these down until they just touch. There are 4 set screws. They're centered between the mounting bolts, and if you thread them in just till they touch, you don't want to actually push. Then when you lock the bolts down, it stays lined up. It works pretty well. Now everything's lined up again. This boring bar isn't the smoothest either. It's It's an old homemade bar. Oh, come on. I made it a while ago. It's got a couple burrs on it. It's been used a fair amount. This homemade bar has round holes, and when you put the square cutters in, it tends to make a little apart. I gotta get burr. The head bearing off to weld it anyway. I can leave the tailstock bearing on for welding because I don't need to stick out that side. Got all pieces. You might think, these are small holes, why not hand weld them? Well, this is so much easier than hand welding. And I already have the mount welded here to bore it anyway. There's no point in hand welding it. This is just that much easier. And yes, it's an expensive machine, but I already own it, so done. Check length. This is probably overkill, but it's fine. The bore welder kit has a lot of different extensions. You just have to kind of find the right combination. It's a lot of overkill. Too much. This one's just the welding tip with an angle adapter on it. Checking the length of the stroke. Not quite enough stroke to do both holes at once. Probably weld there. Almost. I have to slide this. That's not that bad. Let's get it welded up. So here I just have my MIG welder hooked up to it. I've sped it up because you don't need to watch it weld slowly the whole thing. But I've got a controller in my hand. I can adjust the speed at which it rotates, and then I can adjust the temperature and the wire feed speed on the welder. And when you get it set up just right, you get a beautiful weld. You bring it down there to see. This is why I use the bore welder. See how smooth that is? It's perfect. It's like rope. There's coiled rope in there. That's all it needs to get done. And I didn't have to spin around and do all that. The starting pass, you can see right here on the edge. When the wire's hanging out, I get a few bumps. Those grind right off, but you can see how nice and smooth it is inside once you get going. So we'll do the second one, and we'll come back and bore it out. This is just more of the same thing. If the stroke of the bore welder was the same as on the line boring machine, I could just skip the middle and keep going. But I had to slide the machine back. It's really not very hard to do on that bar. You just slide it back and make sure it's centered. As you can see, a pretty good amount of heat into this. Glowing. And smoking. So we're going to give this a minute. Cool off a little bit. I gotta take the bore welder setup off hooked up to my Lincoln here. Just running a Power Meg 215. They're a pretty good welder. I guess it's technically now it's an older unit, but works nice for me. And using my York Smart Weld systems. Yeah, I'll be using a York bore welding setup, but once again we're taking that twisted thing and we're making this one match same dimensions. I think this one is probably a little bit heavier. Base boss looks pretty similar. This one has a grease circ and that one doesn't. And these bosses are larger diameter and wider than those, so we're going to shrink the size of these both in inner diameter and in overall width. It'll be a little bit beefier. Hopefully it'll should all fit. So I'll take this whole setup down and then I'll bring you back to bore it. Alright, we are set up. I have a new carbide cutter. It's set to maybe not hit anything, but I got a couple little goobers on the side started on. Sometimes gets one. I like to do a quick pass just to make sure I'm not going to run something huge. I did check. I have enough stroke to do this in one cut. So they're sitting at, we got to figure out where we're sitting. For height, I know we've got, I think we're about 1.99 diameter roughly. I mean, it's pretty ballpark. It's a rough surface. We need a 2.1700, which means our cutter will stick out of the bar 0.4600 inches. Bar is a hair undersized, so that's close, but it's also hot. So I want to get this roughed in and then make sure it cools down thoroughly, and we'll do a final pass on it. So we're going to take the first quick run. Probably won't hit much anything, and then we'll go from there and crank our cutter out, get a nice rough pass in, and start getting started. I have found that if you skip the first rough pass, if you have a goober sticking out and you take your real pass, you can make a real mess of a cutter. As it feeds in, all of a sudden it bites off way more than it can chew. So I tend to do a quick first pass to make sure I don't have anything sticking out. Then I can take a decently heavy first pass to get it.
Spots are off and start actually cutting. 30, 30, stick out. Go to 4600. So let's do really 0.36. 60 thou. Not the craziest cut, but it'll be fine with a 1/4 inch cutter.
As you can see, I've got a hook holding it. I was getting a little bit of vibration with the small part clamped to my table, so I hooked up my hoist on it just to give it a little bit of support and keep the vibration down. Not in my hand. It's been pretty good.
Pretty healthy cut. About 193, that's still good.
Sometimes just run the cutter in just a little bit, take a light touch just to check the measurement, because if you overcut it, you have to start all over again with bore welding. But if you reach in and you just start it, you can get a pretty good idea. You can measure it and see.
Next thing we're going to do here, I've got a long cutter sticking out extra far. We're going to go face this. So I'm not going to use the auto feed. I'm going to feed it by hand. So I'm going to turn it on. I'm going to feed it and just clean up this face. Get rid of the little bit of weld that sticks out. Make sure it's true. So I'll go and come up and clean it up. Back it off, stop it. We'll stick the cutter out a little bit more and do it. We'll see how many times we do. Probably need a couple times to get a good face. we'll turn it around, do this other side, and then the outside faces we got to take back at least 1/4 inch. I think that's going to be easier to do on the Bridgeport. So let's get this going.
If you're confused, I cut out a bunch of passes because you can't really see much in the camera, but a lot of measuring and boring, and at this point they're at final inner diameter, and I'm just fixing the faces where I've got the weld build up. So I stick the cutter out, take a little bit off, hand feeding it, stop the machine, stick it out more, feed it, and I can, in a few steps, cut a pretty good face.
Here's our first pass. It's looking pretty good. We're going to stick our cutter out further. Adding a fair amount of bite each go here, but I'm feeding gentle and we're getting there.
The quick method is, of course, to reach in there with a grinding wheel on an angle grinder and smooth it up, but it's not nearly as precise or a nice a finish on certain machines where there's a lot of shims and it's sloppy. It works fine, but this is a much better way to do it if you have the time and opportunity. You can see the face is starting to develop. As the cutter comes out, it gets a larger surface cut. And when I touch it, you'll see that shiny, smooth machine surface grow. There go the chips. And since my cutter has a nice square face to it, I'm touching the whole surface back so it doesn't have a bunch of steps.
And this isn't quite as fast or slick as having the facing tool, but for the price, can't really beat it. You can see that left a pretty good finish on there. Got a few BBs out here. I'm not going to worry about those. I'll just touch those up quick. But that's a nice machine face. It's perfectly perpendicular. You can see I just stuck the cutter out extra far on one end. You can also see at this face, if I just squared it up, would have been quite right. I've got a little bit of a lip over here. I'm actually a little bit proud inside here. So this ear is actually not quite straight on this link. So doing that, we'll have a nice surface. This, I'm just going to hit this outside with a little flapper wheel just to get these BBs off. This is for an excavator. There's a cylinder going in here. It's got shims. It's pretty worn. I don't want to really change the dimension, but if it's off a few thou, it's really not critical on this particular application. Sometimes it is, but not this one. So I'll do that again on this face. You see you get these weld, that's about what this one looked like. When you start in, the welder can sometimes go bloop, bloop, bloop as the wire tries to miss the edge. But if you start too far in to avoid getting these lumps, you don't get a weld all the way out. So usually it's best to accept a few bumps out on the outside and machine them off afterwards, and that way you'll have a full all the way to the corner weld. And it works pretty nice. On this side you can see I think there's one little dimple here where I didn't quite get enough weld in, but on this application that's fine. It's really just on the surface, and it's probably even above the edge of the grease, so I'm not worried about that. This will be good. I will do the other side, then I guess I'll bring it back. We'll take the whole setup down, and I'm going to put this thing in the Bridgeport to take the sides off of these, because I'm doing the inside faces as you're seeing,
The outsides I need to cut about 1/4 inch off because they're too wide for where they're going. So we'll put it in the mill and we'll take those off next. I'm going to take a light pass and measure and just make sure it's square, and then we'll go to final depth. I took it pretty easy on this. It wasn't the most rigid setup in the world, but it worked well. If I had an auto feed, it'd probably look like I'm moving out it quite as much, but this is an all manual mill, so just gotta crank it if you want it to move. This did come out pretty well. Once the first side was trued up and machined, I was able to flip it over and do a couple measurements and get the other side pretty easily. And as I said, it's for an older machine, it's a little sloppy, so if it's close, it's pretty good. This is certainly more precise than the rest of the machine is. Not perfect, but I think that's close enough for what we're up to. These things are really slick if you need to pick up machining chips. They aren't expensive either. They're good if you're working outside the dirt too, where you can't sweep. Pretty sweet. Pretty cool. Check it out. A lot of chips. I'll take a little whiz wheel and just give it a nice screw it off, but that's about right for flip. Flipped over, clean the other side. Got it mostly milled off with those small 1/4 inch cutters that I was running. Weren't stiff enough to really do the outside edge without having problems. So here, I'm just finishing milling the face off. I set the thickness of the overall part, so this is the final cut. And kind of lost the next section of the video, so it came out beautifully, and it went and fit, and I put it in.